Hi everyone, we're going to discuss the polar equation and graph by hand. We know that this has the form of R equals EP over 1 minus E cosine of theta. So the first thing I need to do is put in proper form because we need a 1 here. So I'm going to rewrite this as 9 over 3 times 1 minus 2 cos of theta. Alright, and then I'm going to go ahead and simplify here. 3 goes into 9 3 times. So let's discuss this. EP equals 3. My E equals 2. Therefore, my P, I'm going to plug in my P. So 2P equals 3. So P is 3/2, or 1 1/2. Now E equals 2, which is greater than 1. So therefore, this is a hyperbola. All right. The directrix is perpendicular to the polar axis because it's cosine. All right, and it's going to be 3/2 units to the left of the pole. Remember, cosine is left and right, and since we have a minus here, that means it's going to be to the left. All right, so let's go ahead and start graphing it because I like to graph when we're doing the other information. So basically, our directrix is at 3/2, so 1 1/2 to the left of the pole. Here's our pole, and it's perpendicular. This is cosine, right? So it's perpendicular here. Let me make it more in the middle. There we go. Something like this. Now, to find out the vertices, we're just going to be plugging in, since this is going to open up to the left and to the right, we're going to plug in 0 and pi. In our equation, let me write it again. R equals 3 over 1 minus 2 cos of theta. So I'm plugging 0. Cosine of 0 is -1. So we're going to get, that's going to end up being -3, 0. So basically we go over here from the pole. We have -3, 0. 1, 2, 3. 1, 2, 3. And when I plug in pi, I get pi, it's -1. So let me go ahead and write this. So 3 over 1 minus cosine of pi is -1. And that's going to give you, this is 2. So that's going to give you 1. Let me reerase this and do it again. So we're plugging in 0, so we get 1 minus 2 times 1 equals 3 over -1, which is -3. So that's your 0 here. Remember, you're at 0, so you have to go to the left. And then when you plug in pi, you get -1. So that's 3 over 1 minus 2 times -1, which is going to be 1. So at pi, it's at 1. So we're still at over here, and there it is right there. Somewhere right in there. All right? Now to get the points on the axis here, the y, I'm going to use pi over 2 and 3 pi over 2. So we know that cosine of pi over 2 is 0. So we have 3 over 1, so that's going to be 3, 1, 3, basically 3 over 1 minus 2 times cosine of pi over 2. Cosine of pi over 2 is 0, so that cancels out and you get 3. So we go to 3. 1, 2, 3. So this is 3 comma pi over 2. And the same thing's going to happen when you plug in 3 pi over 2. It's going to be 3 comma 3 pi over 2. Because cosine of 3 pi over 2 is 0 as well. Okay, so we can kind of draw it here. Here's your vertex. So it opens up, something like that. Alright, and the other one you just have to kind of mirror image it. So this was negative 3 comma 0. And I'm not good at that on the iPad here, so let me go through and kind of goes over 1 to 3. 1, 2, 3, 1. I'm just kind of making it symmetric. So something like that. So there it is. And if that's all you have to do, you're good to go. If you want to find the center and all that, we can do the center at, find the A. So A is going to be 1/2 of 3 minus 1, which equals 1. So the center is at 1 plus 1 comma pi. So we go pi and then we're going to go down 2. So the center is going to be right in here. Here's your center and go down 2. It's right there. I'll put it in black. Alright? And then this is going to be 2 comma pi. Now, so basically C equals 2 minus 0, which equals 2. Sorry, C is 2 because we're taking this part from 0 to 2. And so the second focus is going to be at, this is our first focus. And our second focus is going to be 2 plus 2 comma pi, which is 4 comma pi. So we go 1, 2, 3, 4 right in there. Thank you and have a nice day. Bye-bye.